This is the story of how I used engineering to solve this seemingly impossible puzzle. Why? Because I am better at engineering than at solving puzzles. It all started with me trying to give my wife a little present. She had been studying for her medical exams for months, and so I wanted to give her a little something. So I started searching and I found this. Well, not exactly this, but what happened was I worked for this university lab, which is the DIM lab, and there's a student in the past who had worked with one of the professors to come up with an ingenious design for this puzzle. He had posted the 3D printable version of this, so I downloaded that, and since I do not have a 3D printer at home, I asked one of my friends to 3D print this, and he did. So this right here is the 3D printed version of the puzzle. The puzzle seems to be straightforward. You see, it is a maze inside of a cube. It has evenly spaced holes which are in the pattern of 5 cross 5, and the holes run from top to bottom, right to left, and from front to back, so all the way through. Now, the catch here is that you have to insert a marble from one of the ends, which is marked as start here. You put the marble into one of the ends and you have to make it go all the way through the maze and make it come out of one of the ends, which is marked end. And the holes that you see are of two sizes. The first size is just small enough to not let the marble pass through, and the other size is just barely enough to let the marble pass through. So you see, it kind of forms a maze. And the good thing is that the solver can at all times see the marble as it goes throughout the maze. I knew that solving this would be challenging, but I had no idea how much. So I just gave it to my wife when I went to pick her up from her exam center, and she played around with it for the most of the 1.5 hour journey. She couldn't finish it, so when we came back, it was just lying around in the corner of the house, and then off and on I used to pick it up and I tried solving it, but I could never get to the end, or not even halfway through. That got me thinking, what if the cube wasn't printed perfectly? I know that my friend who 3D printed it used structural supports, and he later broke those supports by hand. That is the reason you see these small irregularities around the holes. And even if there is a small irregularity, that would make a passable hole smaller than the diameter of the marble and essentially making the cube impossible to solve. So, being an engineer, I tried to rule out that possibility. I downloaded the 3D files from the internet and I opened them up, and my idea was I'm going to look at the files layer by layer and see where the big holes are. And then I would take this physical model and ensure that my marble was passing through all the big holes that were supposed to be in the model. And that would make me figure out if it was printed properly or not. Makes sense, right? However, the idea was a total flop. The reason being that from the 3D model, which was the printable files, I wasn't able to visually distinguish between the small and the big holes. But that did not mean that I could not use one of the fancy CAD softwares to extract out the dimensions. I could just read out the dimensions, and the larger diameter would correspond to bigger holes and the smaller diameter would correspond to smaller holes, right? However, I soon found out that the files that were available on the internet were only fully compatible for the 3D printer. And so when I opened them up in my CAD software, I was able to view the model, but I wasn't able to do anything beyond it, let alone taking out the dimensions. Now, having failed two different ways, I tried a completely different approach. This time, I fell back on my programming experience. I opened MATLAB, I wrote a small program to model this cube. So the cube was modeled as a bunch of different lines, a big cube which has smaller cubes inside of it. Each smaller cube represented the hole inside of this cube. The only reason I did not make circular holes was because it was easier to make just small cubes. and I marked out the start and the end locations using green and blue color. The idea was simple. I would take the real cube and make the marble move one step at a time, and I would mimic the same motion inside of my computer program. And that way I would get a trace of where the marble has gone. And by following along the trace and by trying to map out all the different ways the marble can move inside of it, I would essentially be able to figure out if the cube was solvable or not. So if I made the marble go one step up, I would press W on my keyboard to mimic the motion. I used the arrow keys WASD to represent top, left, down, right motion, and IO to represent inside or outside. Now all that was left was to do try and error and to mimic the motion from the real cube onto my computer model. And so me and my wife, we both sat down to bite the bullet. She was the one fiddling with the cube and I was pressing the keys. To our surprise, there were many paths that had a dead end. Whenever we thought we were making progress, we would always run into a dead end. And after hours and hours of effort, just when we were about to give up, we finally found the path that took our marble from the start to the end. And it was such a relief. We had finally used engineering to solve what seemed to be an impossible to solve puzzle. And the best part was we had a really good time solving it. And that is what we wanted. So if you would like to get one of these cubes, I am going to put a link down in the description from where you can download the 3D printable version of these cubes. Even the more simpler 3x3 cube or the more pro 10x10 cube. So you can download the files, 3D print it, and have one of these mazes with you to play it yourself or gift it to a friend. And now you even know that this is solvable and this is the solution to it. You see, engineering does come in handy in more ways than we can imagine. After all, it's engineering simplified. I hope you had a good time watching this video and see you in my next engineering journey. Thank you for watching.